I'm sure many will be familiar with the term smart grid. This concept has been around for a while and is becoming well established as our demand for sustainable electrical energy increases. The idea of the smart grid is the philosophy of effectively managing the supply and demand of energy to even out the peaks and troughs to ensure the grid can cope. As we move to more use of electric energy for things like heat pumps and EV car charging, this requirement can only increase. Additionally, it's necessary to balance out this demand with the availability of renewable energy, which can be variable due to prevailing conditions. Dynamic billing enables energy providers to discourage energy use during periods of high demand, whilst conversely encouraging demand, for example, to enable EV charging during periods of lower demand. The existing network of high voltage AC power distribution, typified by those large pylons and overhead cables, is used to move energy from traditional power stations to towns and cities that need it. The concept of microgrids is another game changer, the philosophy being that of combining both the supply of energy and the use of energy at a local level. A good example of this could be a university campus that uses its own renewable electrical generation around the site. Additional battery storage can help cover periods of lower generation. So what of DC grids? Well, at its core, the DC grid is all about energy efficiency. Let's consider an example of a site or building that has its own renewable, such as PV, photovoltaic solar panels, and also a number of EV charging stations. Today, the electricity generated by those PV systems is DC power. That must be turned into AC so it can be fed back into the existing AC grid. A device called an inverter is used to do this conversion. However, it's not 100% efficient, so there is wasted energy. Potentially, at the same time, there could be a demand for EV charging. EV batteries are DC too. Thus, the power from the AC grid must once again be converted, this time from AC back to DC to charge those vehicle batteries. This incurs further inefficiencies and wasted energy. It therefore makes sense in such microgrid situations to generate the power as DC, distribute it around the site as DC, and then directly use it, for example, EV charging as DC. Trials of this concept are already up and running. There is much development work required of standards, regulations, and of course the hardware required to support this new infrastructure, but ultimately it will be an important development as we move to a more sustainable future and achieve the goal of net zero by 2050. As an interesting footnote, when power was first distributed in the 19th century, it was DC too. So it's fair to say we may be going full circle. Vargo is a specialist electrical connection, interface and automation equipment provider with solutions for energy measurement, energy management and energy load control.